as a matter of fact, gang, all of the gang minus rotational kinematics. Gang, we're going to talk about this unit. Gang is going to deal with center of mass and the rotational equivalent of Newton's second law and the rotational equivalent of the conservation of angular momentum. So we're going to kind of cover all that stuff in this unit. Gang, center of mass. So I want to start out by talking about center of mass. Gang, your book doesn't do a very good job on covering this. Gang, it turns out our conceptual book with Paul Hewitt does gang a great job on covering almost everything in there. One of the best teachers out there, Mr. Hewitt. Gang, I take a lot of stuff out of his textbook in this unit. Okay, gang. Hey, let's suppose that I take a ball. Take a golf ball, a baseball, a bowling ball. Again, I toss it in the air like this. You guys don't do bowling ball though, huh? Again, I could do a bowling. I should have brought out a bowling ball. Again, it turns out when I toss it, again, that bowling ball follows a nice, smooth, clean path. Again, that nice, smooth, clean path, we be calling a guess what? What do you be thinking? It begins with a PA. Ends with parabola. What say you? Let's pop something, Jace. Get a parabola. So again, the path that the ball takes is that of a parabola. Again, anytime anything, again, moves with a uniform motion. Again, a constant motion. Again, a type of motion that doesn't change in one dimension of space. Again, a uniform acceleration in the other dimension of space. The resulting path is always that of a parabola. Again, as a matter of fact, again, in which dimension does the ball move with a nice constant uniform, non-changing motion? I would say, let's pop this out to the national champ, Catherine. I should have Kyle get a picture of the national champ. I bet you all the other fellas at DECA competition would be jealous. How old is the national champ? Class, are you ever lucky? I know, but still, I wish not that they want to date her, just that they want to get her autograph of a national champion, prom and dance and kick and all that stuff. Let's say you look about this on to Catherine. Which dimension does it move with uniform, constant, non-changing velocity?
X.
Very good, gang. She did this, that sign for horizontal. Again, that sign for the X direction, the east-west direction, gang, it doesn't change. Again, which dimension of space does it undergo? Is it undergoing uniform acceleration? It's accelerating with a uniform, constant, non-changing acceleration. Which dimension of space is that? Let's pop this up to Zach Ferraro. Muy bien, getting the up and down dimension, the y dimension, the vertical dimension, getting constant acceleration. Again, how about if I take something like this? Again, this L-shaped object. Again, if I take the L-shaped object and I toss this in the air, again, does it follow a nice, smooth, clean path like the ball does? What say you? Again, that's not easy trying to catch something rotating. That takes some skills. What do you be thinking? Let's pop this up to Tori. Okay, no, it doesn't. But again, it turns out there is one part of it. Again, that does follow that nice, smooth, clean path, while all the other parts wobble about that part. Again, that part that follows that nice, smooth, clean path is what a good portion of this unit is all about. Again, we call that part the left flank plane. Any idea? Let's pop this out to Devin, Trojan soccer player. Hey, muy bien, again, the center of mass, again, or some people say the center of gravity. Again, just like there's a difference between mass and weight. Again, weight isn't mass and mass isn't weight. Again, there really is a little difference between there is a difference between center of mass and center of gravity. But again, in this class, I'm going to treat them as both being the same thing. Again, in this class, again, we're going to use those two terms interchangeably with one another. Again, all objects really near the surface of the Earth, again, where their center of mass is, that's where their center of weight also is. Again, so the center of mass and gravity is just that point. Again, in other words, you can take any object out there that you want. Again, you replace it with a little dot. And that little dot represents where as far as old Mother Earth is concerned, where all the mass, all the particles making up that thing happen to be. So again, with the diver, see that little black dot on the diver? Again, that's where the diver's center of mass is. Again, you notice that follows a nice, smooth, clean, parabolic path. Okay, even if she's doing somersaults. Okay, her center of mass, I don't care what she's doing. Spinning and tumbling as she goes through the air. Okay, her center of mass follows that nice, smooth, clean parabolic path. So again, that black dot represents her center of mass. Again, as far as old Mother Earth is concerned, it reaches up, grabs hold of her at that point, and pulls her straight down, straight towards the center of the Earth. That's where her center is. Again, how about your physics textbook? Again, I actually did this. I got this from the author of this textbook, Paul Hewitt. Again, I want to find out where the center of mass is. Again, it turns out the center of mass of this textbook is guess where. Guess what the location of the center of mass of the textbook is. Again, again, our textbook, I did it with our textbook too. Locating the center of mass of the textbook of Giancali. Again, want to know what? I had a student once. His name was John Carley. And later on, gang, I had a student, foreign exchange student from Italy. And I don't know what led down this, but I asked, he told me that maybe I was just asking him, trying to learn a little Italian. That's why I speak fluent Italian now. Gang, how do you say that in Italian? Giancali. So gang, in English, Giancali, that's how I say it. But again, it turns out he told me, in Italian, it's John Carley. And I had a student called John Carley. He's a little fellow, again, real smart, real bright. He never did any of his homework or anything. But of course, he went on 5 the AP exam, and then I changed his grade. His mom was elated. On top of the world, he wouldn't do anything. And she knew that he wouldn't do any homework or anything like that. But again, he 5 the AP exam, so I changed his grade. Okay, so how do I call him? When I wanted them to pull out their books in the old days. Okay, go ahead and pull out John Carley. That's in Italian. Then I had another foreign exchange student from Italy who said kind of the same thing. That is kind of John Carley, huh? I thought that was kind of neato. Okay, but it turns out the center mass of your textbook is right, guess where? What do you thinking? Let's pop this out to Tony. Okay, right in the geometric center. Okay, we can find out where the geometric center of the textbook is by, again, in the old days you can see I used to do this, but now because of the power of PowerPoint, I don't have to. Again, I took a meter stick ruler, again, connected these 2 corners, and I drew a line for Wumpf. I connected these 2 corners, again, and I drew a line for Wumpf. And right where those lines intersect, again, that's the geometric center of the textbook. Again, that happens to be where its center of mass is. Okay, in other words, as far as old Mother Earth is concerned, again, all the particles making up the book located right there. Right at that particular point, right at the center of mass. Again, I could double check that by doing guesswork. Again, this is a way that you can experimentally kind of determine where something's center of mass is. Again, where its center of gravity is. I could be doing guesswork. Let's pop it up to Al. To find out where the center of mass is. What say you? Hey, dare me to let go with this hand? Okay, how about if you double dare me? Would you double dare me to do it? Okay, triple dare. Oh, he said he stopped at double dare. Most classes I got to go up to quadruple dare. Because they don't get the taxpayer money of this book. If it falls out of my hand, it could get damaged. Okay, here we go. 1, 2, 3. Again, if the center of mass wasn't there, above my fingertips, again, it wouldn't balance. Again, it would rotate off of my hand. Again, these molecules over here, these particles over here, this portion of the book right here. Again, is old Mother Earth pulling down on these particles, but won't with the force? What do you be thinking? Let's pop out to toy. Yes, they have old Mother Earth is. Again, how about this portion of the book? Over here, is old Mother Earth taking pull down on them with the force, but won't? What do you be thinking? Let's pop this one out to Adam. Yeah. You bet, King. How about the particles over here? Is old Mother Earth pulling down on those particles? Let's pop this out to Jace, but won't for the force. Yeah. You bet, but you want to know what, gang? I don't need to support every particle making up the book. Gang, I just need to support it at its center of mass. Gang, old Mother Earth treats this book as if every particle located right there, huh? So, gang, I got this a little demonstration from one of the greatest authors on the planet, Paul Hewitt. Again, that's what the center of mass of the thing is. You don't have to support every single portion of it. So again, the red dot represents the center of mass. So again, really any object out there, you can replace it with a little dot, and that's where the center of mass of the thing is. You can support it right there, even though old Mother Earth pulling down on all the other portions of the object. It will balance at its center of mass. Again, how about if we do this? Again, here it is. I have a Reader's Digest, a very nice book, the Reader's Digest. Again, in the old days, people, all kinds of people, all kinds of nice stories in there. Again, heartwarming stories in the Reader's Digest. Good good story. Look at that pretty flower, huh? Pretty flower, pretty flower. Yeah,
How old
kind of
is
good.
it?
Oh, showing you every page in a Reader's Digest. Gang, watch this, huh? Gang, who's a magician? Gang, guess who knows magic? Gang, guess who maybe has the force? What, gang, is my fingertips at the geometric center? What say you, let's pop this out to Alexandro. That's a little Espanol from all my non-Espanol friends for Alex. That's Alex in Espanol. Alexandro!
No.
No, give it to me in Espanol, Alexandro, for the folks at DECA competition. No! Espanol, it's no. In English, it's no. Down in the hood, it's no. My fingers are not at the geometrical center of the textbook. Freaky. Who's freaked out right now? Nedobeck's doing some magic there. How about this one? This was our old physical science textbook. Way back in the early 90s, we used this one. Watch this, and I'm not going to put my hands at the geometric center. I'm going to make it balance. Who's kind of freaky? Look at that. He's not balancing that at the geometric center. This book is heavy. I don't think you guys can hold it up like this for very long. This is like, look at the balancing skills I have. That's literally amazing. And here's another textbook, a physical science book we had of the pants, huh? Bum, 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 bum. Walty, what's going on here? Is that magic?
No.
What's going on there?
You're holding on to it?
What must be true? King, I'm not holding on to it. Look at the, my fingers are all like this. No, in other words, what Walty is probably saying, oh, we can't see it, but you have your thumb up here. And you're not showing us that the thumb's up there. Again, watch this, huh? All fingers underneath the textbook. Again, my thumb is not up there holding.
Can I sit?
Again, I'm not holding it. Stay after class, you can see it. Hey, what must be taking place there? Let's pop this up to Gus. Maybe Gus be a no.
You're holding it where it's the heaviest.
Hey, gang, it has to be. Gang, the center mass would have to be guess where. Gang, if you're supporting it here, gang, we call that the base of support. Gang, from this finger all the way to this finger, that's called the base of support. You're supporting, gang, that object, this book, gang, within that distance there. Within that area underneath the book. That's called the base of support. Okay, what must be true about the center of mass of that book? It must be located, guess where? What do you be thinking? Let's pop this one up to the King of Jordan. Yeah, you know what? Oh, you didn't have her. First, second, third hour. Her name was, I had her, of course, you called her Mrs. Process.
We have, her brother.
If you have her as a sub ever, you guys didn't get the, she was a student of mine. Her name was Jordan. But you know what, I didn't call her the Queen of Jordan, because her last name was Process. I would say, when doing little math stuff, I would say I called her the processor. Let's have the processor process that one. But know what, Sean, though, all the kids guessed that that's what I called her, the Queen of Jordan. So they must know you're called the King of Jordan. You're well known, Sean. Sean's a smart one. Okay, where must the, he is! Matter of fact, I was going to say something to you coming into class in private. I hope you don't think that, I hope you're not embarrassed by this. I noticed you now signed up for the AP exam. No, I think you can be a very successful one. Zip zap, easy pass it. Matter of fact, I think the B exam you could 5 it. That's how smart Sean is, I think. He's like little John Carly. He could find it, but he does work though. Different thing with John Carly and Sean is he does work though. I know, that's what I mean. I saw that.
Oh.
I just saw it today. That's my point. No, originally, remember I asked people to raise their hands and if you signed up so that we could clear that up, and they went, downtown wanted me to do that. Well, Sean raised his hand and he wasn't taking it. I was like, I don't see anything.
He tried to.
Yeah, I tried to that day.
The website was.
Oh, I see. Okay. Well, I'm glad you changed your mind. What's that?
He didn't. He tried to sign up. But
Oh,
the
I see. He
website
wanted
was
to.
down.
Oh, but then you thought maybe you couldn't. Was that it?
No, the website was down.
Okay. But again, I think you can still sign up if you want.
Yeah,
Can't
I
you
signed up
just-
the day after the deadline, they didn't
Yeah.
charge me the $25.
They did?
No.
Okay, good. See, probably because it's the first time they did the extra 25. The center mass must be located, guess where? I was asking the King of Jordan this one, I think. Yeah, gang, somewhere, gang, within that base of support. In other words, gang, Old Mother Earth pulls down on this textbook, gang, as if every molecule right there at the pink dot, boom. Gang, and as long as that center mass is within the base of support, it's going to be okay. It's not going to topple. It's going to balance. So, gang, really, those textbooks, gang, had a lot of mass, a lot of weight, gang, on this end. And that's why they'd be a balancing. That's why it was okay. Again, gang, showing you where the center mass of all those just different objects are with a red dot. Gang, how about a baseball bat? Gang, if I take, gang, if I measure the distance from that hand, gang, to that hand, gang, and I cut it exactly in half, gang, is that where the center mass of the baseball bat is going to be? What do you be thinking? Let's pop this one out to, where are my baseball players? Sturdy woke up this morning, they had baseball practice. Gang, he came in all juiced up, all on fire this morning, ready to go. Gang, nothing like a little bit of exercise. Gang, that gets the blood a-flowing. Gang, makes you think better. Gang, you should have seen him, because he's in third hour. Gang, in the morning class, he was on fire. What say you, Wolfie?
It's not.
You gotta get up and do some exercise before you come in. That'll make you come in, Walt.
What?
In the morning, get up, do some exercise. You'll come in all fired up. Because I noticed you weren't here this morning.
Yeah, what? I just didn't come in here today.
Oh, okay. But if I measure that distance, boom, boom, exactly halfway between there, is that where the center mass is going to be?
No, it's more to the right.
Hey, gang, it turns out, gang, if I do this, it's not smack dab in the middle. Gang, as a matter of fact, is it shifted towards the left? Gang, that's my left hand. How do I know that? That's an L. Gang, this is my right hand. Why? Gang, that's not an L. Gang, L, not L. Gang, so gang, is it shifted towards the right or the left? Gang, telephone. Sorry about that, Decker Types. Little interruption. My goodness gracious. Hello, Mr. Nedobeck speaking. They hung up. I wasn't the officer. He's going to be mad at me. Oops, I got it. Hello, Mr. Nedobeck speaking. Oh yeah, she's here. I know what, she was so interested in my lecture because I know she had to leave, that she got all caught up with it and she forgot to leave. Okay, at 2:30 she had to leave. Okay, well thank you very much for reminding. And I missed it. Did you call before? I was rushing to the phone and I just missed it. I just missed your call. Okay, well thank you very much. And you have a good rest of your day. Okay, bye-bye. Okay, so gang, is center mass shifted to the left? Gang, that way's left. Why? That's my left hand. Base the L, or to the right. What say you, Andrew?
Well, now it's to the left.
Oh, now it's to the left. Very good. Gang, shifted. Gang, somewhere in the thicker end. That's where the center mass is, the center of gravity of a baseball bat. On the thicker end, where there's more mass. Again, I took this, I think, right out of your textbook. Again, showing again center mass follows that nice. Okay, if I just take and throw this up in the air, follows a nice, smooth, parabolic path. As a matter of fact, gang, experimentally, what can I do with baseball bat to find out where its center of mass is? What little experiment could I perform to find out where the center of mass is, kind of quickly? What do you be thinking? Let's pop this one out too. Let's go with a Tori. You be a no. They balance it. Gang, center mass must be right there within the base of support. Like Wolfie said, it's towards the thicker end. Again, the end that has. Okay, if the center mass wasn't there, and we're going to talk about this later on. We're going to make it to this today. Again, it wouldn't be balanced on my hand if the center mass wasn't located. Again, right above my hand there. Again, within what we call the base of support. From the edge of that hand to the edge of that hand. If the center mass wasn't there, it wouldn't be a balancing. So again, gang, showing you the center of mass always follows that nice, smooth, clean, parabolic path. And this one, gang, gang, I got right out of the text. Gang, they're not throwing this wrench in the air. They took and gave it a little flick, gang, exerted a little twisting force on it, and sliding across the smooth tabletop. And gang, I don't know where is the center. They're trying to show you, gang, where the center of a mass of the wrenches. What do you think that is? Hey, guess what they're trying to do? Show you where the center of mass is. Okay, should I do it another 5 times like I had to do for Luke Spellman? Or you guys have it, huh? Okay, believe it or not, I'm being too kind. Spellman still couldn't get it after 5 times. Somebody else in the class had help them. But that's okay. That's not that. Okay, not everybody gets my little PowerPoint helpers skills. What say you? Let's pop this out to Adam.
It's just below the
I'm trying to show you where the center of mass is with bump, 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 bump,
That's exactly
bump,
what he
bump,
said.
bump. With a guess what now?
white dot.
A white dot! Gang, the white dot is where the center of mass is. Gang, where the center of gravity is. Gang, does it make sense? Gang, that it's located, gang, I guess I could call this kind of the head of the wrench. The part that you use to tighten down the bolt, loosen up the bolt. Okay, does it make sense it's shifted towards that end? Again, it's not smack dab in between the length of this wrench, shifted more towards the heavy end. But again, here's the neat thing. Again, that center of mass follows a nice, smooth, straight line path. Again, if I fling it up into the atmosphere, parabola. Again, like this, gang, it follows a nice, smooth, clean path. Again, I think I got this one out of your textbook. They're trying to show you the center of mass with a, guess what, let's pop this up to check. Let's check with check. And Mr. Jepson said you were going to check for the soldering iron. He's going to have check for where the soldering iron and do soldering for me. How's that sound?
Sounds fun.
Maybe I can find out if Chuck is all mad at me because I'm not going to soldering. So that's how I know he's mad at me. Okay, well, very good. Against the red X. Very good, Adam. And again, they took and flicked this thing across. They exerted a little twisting force on it as it slides across a nice smooth tabletop. And sure enough, getting that X, the center of mass of the wrench, follows that nice smooth straight line path. While all the other parts of the wrench kind of wiggle about that point. Even a projectile, a missile. It will follow the nice, smooth, clean, parabolic path, but even if it explodes, into 1,000 different pieces, the center of mass of all 1,000 different pieces will still follow the nice, smooth, clean, parabolic path the missile would have followed if it had not exploded. What huge law in physics? Says that has to be. That even though it's 1,000 different pieces now, those 1,000 different pieces, I'll find out where the center of mass is at any moment in time. It's following this nice, smooth, clean, parabolic path. Do you know what law of I was surprised. I really was. I was impressed. Third hour knew. The first person I asked in third hour knew. Of course, then when the first person knows, everything knows. So who would like their stock to skyrocket in the classroom? What incredibly huge law of physics says that will be a happening. Who needs their stock to go up in the school? Who needs to be impressing somebody? Of course, not Adam. He's already going out with a national champ. So that's why he's not done. Of course, Gus better. I better not see his hand go up. Because somebody's my lab assistant, like a daughter to me. What do you be saying? Let's pop this out to Tony. Any idea? That's how they say idea in Door County.
Thank you.
Okay, that's a good guess, gang. That's a huge law in physics, Newton's first law. But gang, it's not Newton's first law. Jace?
Oh, I'm reading the questions.
Okay, you're reading. But of course, that's not the question I'm asking.
What's the question you're asking?
Why, even when it explodes, it explodes into 1,000 different pieces that go off all over the place, the center mass of all 1,000 pieces will still follow that nice, smooth, clean, parabolic path. What law says that that's going to be a happening? Jace? Oh, very close, Kath. One word. He was off by one word. What's that? Yeah, again, that's a conservation of momentum. Again, conservation of momentum says, okay, that's like the bullet rifle question, momentum in the system to begin with is zilchola. Again, momentum afterwards has to be zilchola. So again, gang, if I want to find the center mass of something like this object, but once I get to the, again, here is the greatest state in the union. Again, guess what the greatest state in the union is? Again, no, not Texas.
It's Texas.
Again, again, that is a great state too. I love Texas. Again, I was thinking of moving to Texas, But then we got the greatest governor now in the state of Wisconsin. Now I'm not moving to Texas because we've got the greatest state. When we elected this fella, again, no need to be a moving. Again, I'm staying right here in the greatest state in the union because we've got the greatest governor in the union. Hey, what state is that? Let's pop this out too. Okay, maybe Texas was a couple of years ago, but not anymore. What do you be thinking? Let's pop this out too. Catherine, what's the greatest state in the union? Yeah, Wisconsin. You know what I asked Hilly this morning? And he hesitated. He couldn't think, and then it dawned on me. He's from Illinois. That's why he doesn't know about Wisconsin. He had a hard time saying. You know where Illinois got their name from? Lots of noise down there. That's why it's called Illinois, very noisy state. If I were to find the center of mass of Wisconsin, again, we can use a guess one. I think we discussed this in this class already, what this be called. Again, your favorite fruit in the summertime, it's a grape one. And your favorite cartoon growing up as a little kid, Blank the Builder, bum, bum, bum. Guess what would be calling this? What say you? Let's pop this out too. Let's go with Emily. Volleyball champ, Southwest Trojan. In case anybody want to stand up and turn back to the camera and give a little wave, Emily. Give the camera, the people watching, a little thrill. What was I asking that question of? Oh, Emily, that's why I called on you. What were you calling this, Emily? Get a plumb bob. Again, let's make sure things are plumb. So again, we can use a plumb bob to find out where the center of mass of something is. So again, I'm going to use the other side of Wisconsin though, because I can kind of draw on it. So again, what we can do is support it from any point that we want. Let me support it from, again, the greatest city in the greatest state of the United States of America. And of course, Philly said, no, I told him not Chi-Town. Again, Green Bay, Wisconsin. Let me go to around Green Bay, Wisconsin. So again, all you do is support it there. Again, let everything stop jiggling back and forth. Let me help it out to stop jiggling. Again, I know the center of mass must lie somewhere along that line. Looking, where along that line? Looking, I'm suspended from another point. Let me go over here. Let me go to one of the greatest universities in the state of Wisconsin, its location, which would be about right here-ish. UW Platteville. That's down there, Let my plumb bomb say. So I know it's going to lie somewhere along this line. Again, where those two lines intersect, again, that's where the center mass is. Again, if I want to double check that, I can just hang it from another point. Let me go over here. Let's let it all stop jiggling back and forth. And sure enough, gang, look at this, gang. Look at this, gang. Look at that, gang. They all intersect right there. Gang, that's what the center mass of the state of Wisconsin is. As a matter of fact, if I now I want to double check that. Hey, guess what I can be a doing? Okay, notice again at one time, looks like some of Door County broke off. The greatest vacation spot in the country, Door County.
No.
Again, greatest state in the union. Again, the greatest city somewhere around right here-ish. Again, the greatest vacation spot in the union. No wonder we're all staying here, huh? Okay, what can I do to again come up with that the center of mass really is there?
Balancing on a pencil.
I could balance it muy bien. Again, so I'm gonna put my fingers here. Again, dare me to? I mean, one time some of Door County broke off. Bum 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 bum. Gang, why are parts missing out on my things here? Amateurs would do this. And it fell and it broke and they felt all bad about it. That happens sometimes. I let amateurs use my stuff. Sometimes it breaks, so again, I know the center mass must be located within my fingertips here. Looks like again just a little south of Wausau is the center mass of again the great state of Wisconsin.
You should balance it on a pencil.
Again, let's see. Again, let's find the center mass of. Again, let's see who knows their animals. Again, what kind of an animal is that? What say you? Let's prompt this one out to Tori. Hey, it's an elephant, huh? Again, notice amateurs broke my tail off my elephant. Again, I didn't notice this, but they glued back the trunk. I just noticed this today, gang. My tusk is off. Amateurs. Again, as a matter of fact, gang, elephants are very, very social creatures. Again, they're very social. They're very loving and friendly and caring. Again, at one time, they thought that they could tell that just by their social interaction with one another, touching one another. As a matter of fact, I saw a film once where some elephants were separated for like 20 years. And when they reunited the elephants, they were all so happy, and they're going up to one another. And oh, I remember me 20 years ago, I loved you, and everything. They're great. As a matter of fact, at one time, though, they thought they weren't very, they didn't communicate much with sound. Again, human beings can be hearing 20 to 20,000 hertz. Generally, again, music types know this. Again, beyond 20,000 hertz. Again, frequencies very, very high. Again, we can't hear. Again, those frequencies don't do anything to the little tuning fork in here. Again, this room could be saturated with ultrasonic sound. What's that? Your sound was I have no idea. Again, likewise, again, below 20 hertz, we can't be hearing. Again, frequencies are too low. The human ear can't detect those either. Again, this room could be saturated with incredibly loud infrasonic sounds. And what's that? Their sound was, I don't hear anything. Again, they brought out instrumentation that could detect, guess what kind of sound waves. And when they did that, they found out, elephants communicating like mad in this region. Any idea where are my music types? Sometimes they know that. Music types. Just any idea on music type? Again, ultrasonic or infrasonic. All my music types at DECA. Sam, I know is that.
What were the two choices?
Ultrasonic, above 20,000 hertz, 20,000 vibrations per second, or infrasonic.
I'm going with ultrasonic.
Ultrasonic. Annoying, high-pitched, kind of like ultrasonic sounds that the elephants communicate in. What am I doing teaching physics? I should be having one of those clowns. Infrasonic. They brought out the equipment to detect sound waves in the infrasonic, and they found out elephants communicate like mad with one another. Okay, so let me go ahead and do this. Let me support them right there. Again, I know center of mass must lie somewhere along this line, the pump-off line. But again, where along that line? Well, if I suspend them from another point of one, again, where those two lines intersect one another, again, that's where the center of mass must be. Bump. Again, as a matter of fact, if I even want to just double check that to make sure they intersect there, again, I can do a third point, a third place, suspend them. And sure enough, bum, 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 bam! Again, they all intersect right there. Again, that's where the center mass of the elephant is. So again, we can experimentally determine where center mass of anything is, again, using a plumb bob. Another way to experimentally determine is by doing desk rubbing. What do you be thinking? Let's pop this one out to Sam.
Your fingertips.
Okay, balancing, huh? You guys gonna miss that one on the quiz. Using plumb bob and balancing it up. Two possible ways to experimentally determine where center mass is, huh? Sure enough, gang, it balances right there, huh? Right there is the center mass. Okay, in other words, as far as old Mother Earth is concerned, gang, every particle making up the elephant, located right there, gang, at that point, huh? She treats the whole thing as if again, we can replace the elephant with a little particle, again, whatever mass all of this has, with a little particle right there at that point, trapped in between my fingertips, that kind of has that mass. Okay, so again, just showing you the plumb bob. The center of gravity can be found experimentally. Again, I think this is right out of your textbook, this one. By experimentally suspending an object from different points. You can actually find out where the center of mass of the thing is. Again, showing you finding out the center of mass of the greatest country on the planet, where that is. Again, using again the plumb bob to find that out. Now, okay, how about something like this? How about getting this L-shaped object? I think if we want to find out where the center mass of this L-shaped object is. Again, we can use the plumb bob. And we're going to find out something very interesting when I do this. Let me suspend it from this point right up here. And again, I know the center of mass, the center of gravity, has to lie somewhere along this line. Bum, 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 bum. Wump. Wump. So, wump. But where along that line, gang, we'll suspend it from another point. Let me check this point right here. Bum, 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 bum. So again, I know the center of mass, center of gravity has to lie somewhere along that point. Okay, let me do this first though, before I draw that line in there. Again, did the first one, I suspended it from up here. Did that kind of go from here to bum, 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 right there. There we go. Okay, so let me do it from this point. Ba-wump, 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 somewhere along that line. Gang, I have a question for you, gang. Where those two lines intersect, guess what, gang? There's no particles there. Gang, it's outside the object's geometrical boundaries. Again, this brings up a very, very important point, and that very, very important point is this. Again, the center of mass doesn't have to be where there is mass. Again, it doesn't have to be where there is stuff. Again, for this, it's located right about here-ish. Again, I could do this all day long. Try to balance it like this, gang. It's not going to be a balancing. Why the center of mass is where there is no particles, no mass, no wood located at that point in space. So again, this brings up the very important point that the center of mass of something can be where there is no mass. Again, where there is no stuff. Again, how about a pond? Again, where's the center of mass of a pond? Isn't it right smack down in the middle there? A boomerang, again, where there is no wood. Again, the chair, no wood there for the chair. Again, for a cup, again, smack down inside the cup where the liquid goes. Again, no cup there. And of course, gang, your favorite one, gang, before you took the bite out of it, gang, the center of mass would be smack dab in the middle of the donut. Okay, where there is no donut. So again, the center of mass of something doesn't have to be where there is mass. Again, it doesn't have to be where there is stuff. Again, it can be located outside the geometrical boundaries of the thing. Where matter does not exist. Okay, gang, if I take this L-shaped object, and I try to have it stay put right here, oh, problem. Gang, no problem. No problemo. That's no problem in Espanol. For all my Espanol friends out there. Again, if I go like this, I won't. Problem. Won't. problem. Hey, like this. No problem. It's okay. Again, let's take a closer look at that. In the center mass of this L-shaped object, again, is it about right there-ish? Is that where center mass is? What say you? Let's count this out to death. No, gang. It's more like right there. Gang, where there is no mass. Excuse me, gang, where there is no stuff. Where there are no particles. So, gang, what does that mean to say that the center of mass located right there? Again, where there is no stuff, no particles, it's outside the geometrical boundary. Again, as far as old Mother Earth is concerned, again, she reaches up through the atmosphere, grabs hold of this object as if every particle making it up right there at the red dot. Again, pulls straight down on it. Again, underneath the center of mass is, guess what? Begins with an NO. Ends with ing. What do you be thinking? Let's pop this one out too. Let's go tori. Nothing, gang, there's nothing down there. Gang, as a matter of fact, gang, the last point of support is right there. Gang, that force is going to cause this thing to rotate about that point, as if there's a little fulcrum right there. Gang, that force times a very, very special, gang, that produces what we call a twisting force. Gang, twisting force, we're going to give a fancy name to it. But gang, twisting force is the rotational equivalent of a net force. Gang, if you have a net twisting force acting on something, again, later on, we're not going to say twisting force. We're going to say something that begins with a T. Ends with or. What do you be thinking? Let's pop this out to Jace. Again, torque. Again, whenever there's a net torque acting on something, it's going to make that something rotate. Again, if you want to change the rotational acceleration of something, what it takes is a net torque. Again, net forces change the linear acceleration of things. Again, this twisting force, which we call a torque, again, is this force. Take that force, gang, which is really just the weight of the thing. Whatever mg is, that's just good old mg. Gang, multiplied by a very, very special distance that we call the lever arm distance. And that's how big or how small the torque is going to be. Gang, the lever arm distance is always, always, always. Gang, the shortest distance between this line of force. Take this force, gang, extend it up indefinitely. Gang, extend it down indefinitely. That's what we mean by the line of force. Again, the shortest distance between that green line and the point about which rotation takes place, that's the lever arm distance. Again, it's always going to be, that perpendicular distance right there. Okay, some people say, well, why not go from this point, again, up to that point? Is this not the shortest distance? Again, really, there's an infinite number of points on that line. Of course, we could go from that point up to that point. Again, it's still not the shortest distance. Again, the shortest distance is always going to be this perpendicular distance right here. Again, that's always the shortest distance between the line of force and the point about which rotation takes place. Okay, it's always going to be this orthogonal distance, this perpendicular distance, this normal distance, again, this transverse distance, again, that's always the shortest distance between the point about which rotation is going to take place in the line of force. Again, the bigger that distance is, the bigger the torque. Again, the bigger the force is, the bigger the torque. Again, the torque is directly proportional to both this force that's tending to want to twist and produce the rotation, again, and the lever arm distance. So again, gang, this now is the rotational equivalent of a net force. Gang, net forces make things undergo linear acceleration. Gang, net torques make things undergo rotational acceleration. Gang, if something's not rotating, and it starts to rotate, it's because there's a net torque acting on it. Gang, if something's rotating, and it stops rotating, it's because there's a net torque acting on it. Net torques change the rotational state of motion of things. Net torques make things undergo rotational acceleration, just like net forces make things undergo linear acceleration. If you want something to undergo linear acceleration, it has to be a net force acting on it. Again, if something's moving but not changing how it's moving, again, no net force acting on it. Again, it's the same with rotating. Again, this system right now, again, isn't rotating. Why? There is no torque acting on it. Again, when I try to balance it like this, again, there's a torque acting on it. That's why, again, it rotates down. That rotation is because there's a torque acting on it. When I balance it like this, gang, there's a torque acting on it. Gang, like this. It balances, gang. It stays up, wide. Gang, no torque acting on it. Gang, why? Because the center of mass is within the base of support. Right here for one. Gang, base of support, no lever arm distance. Gang, tuck this thing in between the base of support. If it was really over there, if this was all lead, that was like styrofoam, then the center of mass would be here, but no lever arm distance.
So then you could balance it.
Then it would balance. Muy bien. That means very good for all of my non-Espanol friends. Just in case, because we're taping this, there may be other people in the audience watching right now, at home in the hotel room. So just learn a little Espanol there. So again, here we go, again, some equivalents. Again, we said last semester that things undergo linear acceleration. And that linear acceleration depends upon two things. Okay, now we're going to talk about the angular equivalent of that. Again, the angular equivalent of that is the Greek letter A. Again, not the English A, but Greek letter A, which is, guess what? Let's pop this one out to the king of Jordan. Again, that's alpha. Again, rotational acceleration. Again, now how much linear acceleration you get depends upon dos ideas. That means two ideas for all my non-Espanol friends. Again, what is one of the ideas that determines how much linear acceleration you be getting? Any idea? Let's pop this out to Gus. Hey, muy bien, okay, the net force. Again, the bigger the net force, again, the greater the linear acceleration. Again, no net force, no linear acceleration. Well, now, again, what is the rotational equivalent of a net force? What do you be thinking? Let's pop this out to M. A net torque, and this now is the Greek letter tau. Okay, the Greek letter tau, kind of like a fancy T, represents torque. Okay, but how much acceleration you get doesn't depend just upon the net force, but also guess how much what the system has. What do you be thinking? Let's pop this out to F. Okay, mass. Okay, how much inertia it has, how much laziness, stubbornness, resistance to change in state of motion it has. Again, the more mass, the less acceleration. Again, the same is true of rotational acceleration, but it depends upon an idea that we call, I guess I could call it rotational mass. Again, or what we really do call it is rotational inertia. Again, we leave this symbol kind of like a capital letter I represent rotational inertia. Again, it's the laziness, the stubbornness, the resistance that all systems have to a change in their rotational state of motion. Again, I'm going to spend probably a whole period just talking about this guy. Maybe 2 or 3 periods. Okay, right. Almost 3 periods again talking about this guy. Again, rotational inertia. Again, prior to this class, again, in physics B, again, we would deal with, again, when it came to linear acceleration, we would say, okay, let's allow it to undergo linear acceleration, and we'll do all of our Newton's second law problems. Again, prior to physics 1 now, again, we never dealt with really rotational acceleration. Therefore, again, the net torque acting on all systems that aren't rotating had to be equal to 0. So again, a huge problem for physics B types, as a matter of fact, it was never on the free response, always on multiple choice, would be the seesaw. Remember as a little kid playing on the seesaw? You would sit on it, and then your friend would adjust where they're sitting, and it would be balanced. Why, gang, that torque 0. Okay, gang, have an enjoyable rest of your